Light is enough. Okay. Uh, we have another MacBook Air. The description says dead, which means no power. First and first, as usual, we want to identify what state we are in, and then we can move forward from there. So let's start by taking out the back screws. As you guys know, we always hold back from connecting the charger until we have an idea, a better idea as to exactly what state the board is before we connect our charger. Especially if it is liquid damage, we don't want to further escalate the issue on the board. Okay, so the back cover is out, and we don't really see any sign of liquid. And by the way, they said the job is urgent, so we'll be quite quick with it. So first, now that we don't see any sign of liquid, the next thing we want to do is we want to connect our charger to see what stage we have with the machine. Okay, charger is connected. We have charger communication. Because we have charger communication, LED, it tells us that we have PP3B42. It tells us we have PPDC in. Next thing we want to confirm is if we have PP bus underscore G to the hot. And we can just disconnect the battery to help us get a better readings on our PP bus underscore G to the hot. Black probe to ground, and then red probe on our fuse here. The last machine we worked on was a MacBook Air, A1466. It was a 2015, and because of the JTAG here, we can confirm that this is also 2015, 2017. So we can use the same last logic board that the board we worked on the last repair. So we can use that in this repair. So now let's see what we have on our PP bus. Voltage is that we can get that on F7140. That is the fuse on our PB bus. So let's see what we have on our right hand on the one side of it. We have 8.6. That's good because 8.6 also tells us that that section of the SMC is also allowing it to go to 8.6 instead of 8.2. Let's see on the other side. Okay, let's just check again. 8.6 is yeah, and then on the other side we have 0. So this is something that I talked about in my previous video. So um, on the fuse we have 8.6, but on the other side of the fuse we have 0. So that will tell us that we have a short on the. So we check this side, pin 1 we have 8.6, and then the other side, pin 2, we have 0. Uh, so what would generally that would mean is we have a short on the side of the board, and oftentimes it will be one of the tantalum caps, this section and this section. Yeah, that would be affected. So the next thing we want to do is we want to take out the board and then find out. But I can confirm that indeed we will most likely have a short. Let's just confirm that, because if we didn't have a short, the fuse would obviously, let's just say on the other side. Yes, that is a short. So indeed that is a short. So the next thing we want to do is we want to, okay, the screws of the battery has already been taken out. That was not by us. Let's now take out the screws on the board and then quickly find out which of the tantalum. Most likely I can tell you that it's a tantalum cap that is being affected. But in order for us to clarify that to be the case, we need to take out the logic board and find out which of the tantalum cap or which of the cap is affected on the rail. From experience, I can tell you guys that it's a cap on the PP bus line that's affected, and it's one of the tantalum caps. So we just quickly taking out the board and identify the cap that is affected. So the way the problem is generated on the board is because the tantalum cap has two terminals. Terminal A is going to be connected to the main line, and terminal B is going to be connected to ground. So Now, on the design of a cap is such that it has an insulator, which is basically the material that separates point A from point B, or that separates terminal A from terminal B. So because it has two terminals, one being connected to ground and then the other one being connected to a power line, when when the cap is faulty, the terminals that separates both will no longer play its role. Now, when that is not playing its role, what then happens is whatever is connected on terminal A will be connected to terminal B. Whatever is connected to terminal B will be connected to terminal A. So that way, that is how you identify. Uh, that is how it then becomes a short. So, so uh, we can. So this is actually pretty obvious. So here I can spot it here. This cap here, it's burnt out, and you can also see the burnt marks around it. So this one here, it's our problem. So what we want to do is we want to take that out and then see if that solves the problem. Okay, the cap is out. One way we can, so let's flip the cap and see if, so the one way we can, yeah, this is was indeed our problem. If you look at this section of the cap, I'm just going to show you guys. See, it was burnt here. So that's the burnt mark. So, and then another way you can confirm that indeed the cap itself is faulty is you can measure the cap out of the circuitry like this, and that is, as you guys can see, that the cap itself is more like a wire. Now let's now see with the cap outside the circuitry. Let's see what we have, and the short is gone. Now we have open line. So we no longer have a short there. So for this one, what we basically need to do is we replace that cap and then we replace our fuse. We have the option to run a wire on our fuse. We may not replace the fuse, just run the wire, but let's just rather replace the fuse and also replace the cap, and then we'll be good, and that will be the end of the repair. We may just put a wire or replace it. What do you think? Replace it, put a wire.
It's easy to replace.
That ways. And just anyways. So now you can replace it because you have confirmed that indeed you no longer have a short on the other side. So if you have a short, you would first want to address that short before you replace it. So let's get a donor. Let's just confirm that this fuse here is good. So for a fuse, you should have continuity when you place your meter on both sides. 1.6. That's pretty much enough. We need to also replace the battery. The battery is becoming funny now. The reading it's becoming inaccurate. Not completely out of specs, but yeah, it's best to get another battery. Okay, that's the cap, and let's get this fuse out as well. Okay, that's the fuse. And this, as you guys, this is a polarized type of cap. You can see the color here that symbolizes that's going to be the main, and then the other side will be ground. Now, for your fuse has no orientation basically, so either side is the same. You can flip it either ways. It's the same thing, but this does have orientation, as you guys can see. So this has to be oriented in a particular order. It's it's a polarized cap, which would mean that it has the polarity has to stay in a particular way. Okay, so with that, what happened here? Okay,
Didn't use it.
okay. Mm, let's just put a little bit of flux and a little bit of soda. A little bit of soda on the pad before we replace it. When I place the component, which is in this case the fuse, the soda will melt better. And also with this, I'm just gonna have it just a little bit there. When I place the component, it's gonna melt better. Uh, okay, that is in place. So now let's clean the sections we walked. Important, we keep the board clean. You don't want to have a board that is messed up with flux. The other cutting board from the last repair, did you take it away? Okay, and let's try to wipe that up. Let's take this out so we can get room to clean underneath it. That phone is not charging, eh? The one on your desk. We have a new addition to the team. His name is Abraham. Abraham. So he's the micro soldering guy. He's very good at what he does. Can I have a bit of time of this? Oh, you didn't see. So this was exact. So the video that we did, the previous video, this was exact. The same like an exact. Okay, not an exact scenario, but the description we had about a blown fuse and check for sure. That was exactly what we had with this board.
Okay.
Yeah.
In the PCA or
No, no, no. Remember when we talked about a blown fuse and then find out why the fuse is blown and then
so it was the
a tantalum cap. This one.
like up on the combi accents what?
Yeah. Can I please have the
What?
paste CPF? Yeah. The big one. Yeah. Okay. So it was exactly like that same scenario. Yeah.
Different problem.
No, no, no. Obviously, it came in dead, but I'm saying in terms of because remember we mentioned about first you need to identify that you have a short and you find out why the short is there before you just go ahead and replace it because
Yes.
otherwise you may be creating the exact same thing.
So the shot was on G3 volt, right?
Yeah,
The
PP
device
boss. Obviously, it will identify as being a short on PP boss even though it's not directly. And then you could see the cap. If you can maybe when you later when you check out the video you see it, you see the beginning of the repair and
So did you see this with the bed eyes or in T-junction?
nah you, that you don't need no, that is too big even. That's too big actually. That's too
Too
big.
big.
Yeah. Smaller than that, alhamdulillah I can't see it with my bare eyes. Okay, so that now that that is done, the next thing we want to do is we want to see if now we should have a working board. Now we just hope in very rare occasions will that also affect the CPU, but that's very on very rare occasions. Oftentimes the cap just dies alone without anything that's been affected. Um, yeah, and your CPU will still be fine. So let's just confirm that.
So do you need to replace it or just remove it and
Yeah, you replace it.
then replace
Yeah,
it?
but then you choose you can choose because of the amount of carbs that you have there that are doing exactly the same thing. You can choose not to replace it, but you should. Yeah. Okay, so we have a spinning fan, but that's not all. We want to see if we have um, if the machine is posting because that's the ultimate. Just a spinning fan is not enough. We want to see if the machine is posting and pretty much the cool stuff. So with having an Apple logo, it's one big progress, and then the machine not crashing, it's another progress as well. But obviously that can be picked up from running the machine. So first and first, let's see. So usually when they talk about if the machine is posting or not, so once you get a chime, once it chimes, obviously that tells you that the machine is posted. Okay, that's really good. And okay, we got an Apple logo, like we got a backlight, and then we went back. So we're not sure what the state it was. Okay, that's good. So that's an Apple logo. So we just also hope that it's also not just good. Okay, that's good. It's an Apple logo, and then we put it to desktop. What else I wanted to say? So okay, obviously we don't expect to have the chime sound because the sound is not activated. We don't have the card. So guys, that is basically it. This repair is complete, and then we'll just move on to the next one. So we will be working on a continue. So okay, let's get to the video, and then we can work on that real quick. So guys, I see in the next one. This is ready. This is gonna go through the testing phase, and the device can be collected. It's the job card number 1569. You can call him to collect since you said it's order 1569.